All right then, explorer. I'm not sure where you live. For me, it's pretty wet. Windy, drizzly, rainy, sodden, and we need to escape. I need to get away from planet Earth. Will you join me? Let's get to it. It's a brand new Fun Kids Science Weekly. My name's Dan. On the podcast, where we explore all the true science secrets lurking around the solar system, we will answer a huge question, one that has plagued scientists for years. Why do we hiccup?
When we have the hiccups, the reason that we make that silly noise is because there's actually a huge muscle in our belly called the diaphragm, and it contracts when we have the hiccups. And so maybe this brainwave is the baby feeling that sensation, and every time they have that sensation, they get a sense of, oh, okay, that's where my diaphragm is.
And we'll look at old animals in this week's Battle of the Sciences.
The understanding of how and why animals changed in the past will really help us in understanding how they will change under the current, climate changes are ongoing, and how we can perhaps help populations and species when they struggle with the current climate change.
Plus, our dangerous Dan is one of the longest creatures in the world. You can find out all about it. Let's get to a brand new Fun Kids Science Weekly. We'll start with this week's Science in the News. We're getting very spacey today because a spacecraft that will hunt for signs of alien life on one of Jupiter's icy moons has blasted off from Florida over in the United States. The Europa Clipper will now travel 1.8 billion miles to reach Europa. It's a deeply mysterious moon orbiting Jupiter. Now, it won't arrive until 2030, so 5 years? But what it finds out could change what we know about life in our solar system, because experts think that perhaps trapped under the moon's surface could be a vast ocean with double the amount of water on Earth. And we've often heard that for signs of life out in the universe, water is a brilliant place to start. It could hold the key, and I love the fact that we're thinking long term, even 5 years into the future. Let's stay in space. You might have seen the brilliant video of this. SpaceX's Starship rocket has completed a world first after part of it was captured on its return to the launch pad. This looks incredible. The SpaceX rocket's lower half dropped down through the sky, and then it moved back towards the huge launch tower, where it was caught in a giant pair of mechanical arms. It grips it, kind of catches it as it's falling through the sky. It's part of its 5th test flight. It brings SpaceX's ambition of making a fully reusable and rapidly fireable rocket a big step closer. And I like this, because I enjoy the fact that we are trying to explore the universe again, but we need to think sustainably. We can't be too wasteful. So reusing rockets, that's very helpful, much more cost effective, and much better for the environment. A good job. And our final story this week, visitors to a natural history museum will have the chance to have conversations with animals on display using generative AI technology. The University of Cambridge's Museum of Zoology has picked 13 specimens for chats, including the extinct flightless bird, the dodo, the narwhal, the bluefin whale skeletons, there's a red panda and a preserved cockroach. Let's find out more with Assistant Director Jack Ashby. Jack, thank you so much for joining us. When was the first you heard of this idea?
It was back earlier this year. Group of people from an organisation called Nature Perspectives who work on trying to make artificial intelligence useful for getting people excited about the natural world. And they were really excited about seeing whether they could use it in a museum like ours. So they got in touch and said, would you be interested? And we said yes.
Okay, so you've got this company that are trying to get you and everyone else excited, but you've picked 13 specimens for these conversations. I've listed a few of them there. A few are even extinct. Why have you chosen these creatures?
Well, we've got an amazing collection in the University Museum of Zoology in Cambridge. We've got about 2 million specimens covering the whole of the animal kingdom, all of kind of time that complex life has existed on Earth. And we chose objects, specimens that have a real mix of different traits. We've chosen some that are skeletons, some that are taxidermy, some that are whole pinned insects, just to see if that sort of thing affects how people talk to them. We've also chosen things that are really common and well known, like mallard ducks that you might see in parks or rivers, and then really, really rare things like red pandas, but also, as you say, extinct things, some that are extinct for hundreds of millions of years, some that have been extinct for just a few centuries, like the dodo. We've also got we've got the only real giant ground sloth on display in the UK, which is this 4-ton behemoth of a sloth. And we've put that in there as well to see what people might want to ask it.
And it uses generative artificial intelligence. So what does that mean? How will AI allow us to have a two-way chat with these creatures?
Right, so I'm not the techie guy, but my understanding is what we've done is we've told that the AI model, we've told the brain, if you like, of this project, everything we know about each of the specimens. So what are the individual animals' stories about, for example, how they died, how they got to Cambridge, and what we've done with them in the museum. And on top of that, we've told them everything there is to know about the animal, the species itself. So what does kind of the world know about red pandas or giant sloths or dodos? And we've put that all in the mix. And on top of that, Nature Perspectives have given these specimens a kind of personality. So they've got a kind of a frame of how that individual animal might behave and respond to questions. So using all of that information, the artificial intelligence brain comes up with the answer to anything that you might ask it. So you could ask it something pretty simple, like, where did dodos live? Or what do cockroaches eat? But you could also ask it something much more kind of profound or unusual that you wouldn't normally see in a museum, like, what was your favorite music? Or, what kind of books would you like to read if you could read?
With the whole wide range of creatures that you've got, from all kind of ends of cuteness, really, I would say, with the red panda and with a preserved cockroach, what ideas do you have about where people are going to stop and try and have conversations? Are you expecting a few animals to maybe be a bit lonely and people not want to chat to them too much?
No, I think all of them are very eager to chat. Some of them, as I say, extinct for a couple of 100 million years, so it probably felt pretty isolated at that time, or they've been in the museum for 150 years not being able to speak. So, of course I'm being playful, but the idea is that they all are eager to chat. And the project started yesterday. In that time, they've all been very, very, enthusiastic with talking to visitors.
And what you're doing is pretty groundbreaking. I mean, I've never heard of AI technology like this being used at a zoo and museum like yours that brings once extinct creatures to life. You're the assistant director there, so you're planning for the future. How excited are you for the potentials of AI and what it will allow you to do in your museum to try and get people through the door?
So yeah, we believe, like you say, we're actually the first museum anywhere that has been trying out this way of giving a voice to objects. So a lot of museums have been using AI over the past few years for different things, just like asking basic questions about, what time does the museum open, or just tell me something about the museum in general. But we think this is the first time that the actual objects, in our case, animal specimens, have been able to speak. And it's really it's an experiment. So we're a part of the University of Cambridge. We're interested in learning new things, testing new things out for the kind of museums around the world. So we're kind of just going to see how it goes. So we're going to then share that information with other museums around the world. But I think what's exciting about it is, when we write a label in a museum, when you go to a museum and you read the label, or you maybe listen to a kind of a short audio thing, that's that someone like me has chosen a really, really short amount of text. So maybe like 100 words that you put on a label. And that's a real guess of what we think people are interested in. It's often a pretty good guess. People want to know where animals lived, what they eat, how, what their exciting adaptations are. But through this, you can ask it anything. You don't have someone like me guessing what you might be interested in. You can you can ask yourself what you're interested in. And I think that's a really, really exciting opportunity. And for us, we're just also eager to learn what it is that people are interested in. So we'll be able to see all of the conversations that the specimens are having. And from there, we'll be able to learn, like in the future, what, how do we share information about our specimens, based on what we now know people are interested in.
Now, you say the tech company that you've worked with have given these creatures personalities. Is the dodo quite grumpy because it's extinct? It's no longer around? I'd be quite annoyed, I think.
No, we've asked it that question, and it's like, no, it doesn't feel, it doesn't feel any animosity. It's a complicated relationship with humans, but now, obviously, the people that are responsible for the extinction of the dodo haven't been around for a few hundred years. So there's, none of our visitors are responsible for that. So it's excited to speak and to share its story and to help people get excited about the natural world. Hopefully, the aim of museums like ours is to make people excited about nature. And it seems like all of these specimens have got the same aim as well. So they just want to get people, enthusiastic to learn how wonderful these animals are.
It's all happening at the University of Cambridge's Museum of Zoology. Jack Ashby, thank you for joining us.
Thank you.
All right, then, let's get to your questions, shall we? It's my favourite part of the show. If you ever have anything sciencey that you want answered on this podcast, best thing to do, leave it as a voice note for me on the free Fun Kids app. Or if you get to funkidslive.com, you can't miss it. Click on the big red button, record a message. Let me know who you are, what you're up to, where you're from, and what your science question is, so then you can star in the show in just a bit. We got one of those in a sec. Let's start with this from Alexander, who's in Glasgow. Sent a message to me on the website. What are teeth made of? Well, I'm very interested in this question, Alexander, because the other day I had 6 fillings at the dentist. 1, 2, 3, 4, 5, 6. I was in there for about 2 hours with some big hairy dentist dude shoveling around in my mouth. It was so strange. So I'm very interested in what teeth are made of, because it seems mine are made of marshmallows. They are pants. Your teeth, though, they're probably made of 4 different types of tissue. A tissue is a group of cells. A tissue is a group of similar cells that do a job together. In teeth, you've got the pulp. That's the inner part of the tooth. It has blood vessels. It has the nerves. It's what talking to your brain. It's what keeping them working, keeping them healthy. Outside of that, you have the dentin. That's hard and yellow. It makes most of the tooth and protects it. After that, you have the enamel, which is the hardest tissue in your whole body. It covers the dentin. It lets you chew without harming your teeth. Then you've got something called cementum, which is around the bottom of your teeth, which holds them in place. It's cementum. It kind of cements it into your gum. So, Alexander, that is what teeth are made of. Thank you so much for the question. Let's get on another one. This is a voice note been sent in to me by Raffy. What do you got, Raffy?
Why do people hiccup, and what's the best way to get rid of hiccups? Because I have hiccups.
Raffy, thank you so much for that question. Why do we get hiccups, and what's the best way to get rid of them? I've always wanted to know the end of that. You hear so many stories about how people are sure that you get rid of hiccups, but does anyone actually know? Let's find out. Dr. Kimberley Whitehead is from King's College London, and we can sort this out. Kim, why do we get hiccups?
Well, to answer that question, we actually don't completely know why we get hiccups, which is why they're so interesting. So there are a few different theories. And one of the theories that I have worked on in my research is that they may have been really useful when we were in our mum's tummy and when we were babies. So we hiccup more when we're in our mum's tummy and when we're babies. And one idea for that is that we need to learn how to control our breathing. And every time that we have a hiccup, we get a sense of where our breathing muscles are. And that helps us when we grow up to be able to control our breathing, like be able to take a deep breath in and a deep sigh out if we want to. So now, as we've got older, we don't really need to have hiccups anymore, but maybe they kind of stay with us for reasons that are not really completely understood.
So you have been studying this. How on earth have you been studying the fact that babies need to hiccup when they're in their mum's tummy?
Exactly. So I have been looking at it, and so have lots of other people. So we can do things like ask mums if they can feel their fetus hiccuping, and we can observe babies. And the way that I have been researching this topic is I've been recording babies' brainwaves when they have these hiccups. And I've shown that babies have this specific type of brainwave when they have the hiccups. And so one interpretation of that is that maybe when they have this brainwave, it's showing us that they get this kind of feedback sense, because as the when we have the hiccups, the reason that we make that silly noise is because there's actually a huge muscle in our belly called the diaphragm, and it contracts when we have the hiccups. And so maybe this brainwave is the baby feeling that sensation, and every time they have that sensation they get a sense of, oh, okay, that's where my diaphragm is.
Do you know of any other explanations? Because if scientists don't officially know, there must be a few different ideas kicking about and competing with each other.
Exactly, yeah. So other people have linked it in babies to feeding. So they've suggested that it occurs linked to when the babies feed, and that's where he could have something more to do with feeding as opposed to breathing. But as in lots of areas of science, there's no explanation that completely fits all of the facts and all of the data that we have. And that's one of the interesting things about science, that we have these alternative possible explanations, but actually it's still a bit of an open research question, which is why it's really interesting for scientists like me to pursue it.
I would have thought we've had hiccups throughout human history, because this is always something that people are wondering. We wonder why we have them, how we can cure them. Why do you think we don't officially know? We know so much about the universe around us. Why do you reckon we're still not 100% sure of why we're hiccuping?
I think one possibility is just that they're difficult to study because we cannot force somebody to get the hiccups. And so when we study natural phenomenon, the easiest thing is if we can study something that we can control. So if we want to look at how our muscles contract, we can ask a person to lift up their leg, for example. Whereas hiccups are so annoying that when you don't want them to happen, like when it's an embarrassing situation, of course they come on and you can't control them. Whereas in a scientific setting, when you want to study hiccups, actually, you can't force them to happen. You might have to wait for days and days for an adult to get a bout of hiccups, which is why it's so good to study them in babies, because babies hiccup so often that actually if you're with a baby for maybe 3 or 4 hours, they will likely have a bout of the hiccups.
And it seems that grandparents always have an answer on the second part of Raffy's question. What's the best way to get rid of them? If that's, stretching up, or if that's standing on your head, or if it's drinking water while you're bent over. There's so many different ways. Do we know of any official way to try and get rid of them?
Yeah, so there are ways that you can try to get rid of them. So the classic thing anecdotally people mention if somebody gives you a surprise. But in terms of more official advice for this and any other kind of health problem, the best website to use in the UK is the NHS website. So if you go on there, it has some sensible suggestions like drinking iced water and positions to get into. But the key thing and the frustrating thing, but also interesting, is that none of those solutions are like a fail-safe solution. So sometimes they seem to work and sometimes they don't. And that kind of fits with what I've been saying, that hiccups, even they seem so simple, actually they're more complex than we realize, because we don't even know after all this time, A, why they're caused, or B, how to definitely stop them in relation to those two aspects of Raffy's question.
How amazing is that? Right now, humans are thinking of how we can get our species onto Mars. Other humans are trying to figure out how we can save the world from impending climate crises. Yet we still don't officially know how to stop yourself hiccuping randomly, but it's been an absolute joy to try and figure it out with you. Dr. Kimberley Whitehead, thank you for joining us.
Thank you very much.
Thank you to Kimberley for answering that question, and Raffy for reminding us all that we hiccup and we're not quite sure why, but they aren't half annoying, aren't they, Raffy? Thank you very much for your question. If you have anything sciencey that you'd love answered next week on the podcast, please do leave it as a voice note for me. The best way that you can get in touch as a voice note on the free Fun Kids app or at funkidslive.com. Got a very strange Dangerous Dan for you this week. It sounds gross and disgusting, like something from outer space, but it's absolutely fascinating, like all the best Dangerous Dans are. This week we are headed into the deep soil around Europe. We're taking a peek at one of the longest animals in the world. The bootlace worm is a remarkable creature, and it comes in a range of colours: greys, blacks, deep purples. It slides through the ground all across the UK and into Sweden and Denmark, around the Atlantic and the Baltic Seas, and it can grow to 55 metres. Extraordinarily long. It's like 5 buses long. It's slow moving. I mean, worms are, especially long worms like this. They have to wriggle every single part of their body. It would take ages. They're known for hiding under rocks and waiting. and it's got a brilliantly dangerous way of protecting itself. Strange for a worm, they don't usually have these things. It can make a sticky, slimy mucus that traps predators or competitors. The slime can make another animal stick to itself. If it comes too close, if it gets covered, then it almost freezes. It's got this glue ball around it, it really slows down. And it's full of toxins. Tetrodotoxin. It's the same stuff found in the deadly pufferfish, which was our very first dangerous Dan. That toxin can paralyse, it can even kill small creatures. It's all from a worm, one of the longest in the world, and it's what makes the bootlace worm get straight onto our dangerous Dan list. For this week's Battle of the Sciences, we are looking at a science that has got a word so big with so many different letters I can barely pronounce it. I will give it a go. We're joined by Joanna Pymans from the University of Cambridge to talk all about paleogenomics. Joanna, you have 60 seconds, 1 minute to tell us why paleogenomics is the greatest science of them all. That 1 minute starts in 3, 2, 1, go!
Right, so I look at DNA from animals that lived a very long time ago, like tens of thousands of years. And this includes animals that you might see on TV or in a zoo, such as leopards. But I also work on extinct animals such as mammoths and saber-toothed tigers and dwarf elephants. So what I do is I take these really old bones and I take them into a lab and try to get DNA from it. And because the bones are so old, we need to be very careful not to let any other DNA get to the bone. So we dress up like giant Smurfs. We have these really big blue suits. When we get the DNA from it, then I compare that with the DNA from modern animals that live now, and I see how they relate to the animals that lived a very long time ago. And this will tell us something about these animals that lived long ago and might even be extinct. And we would not know that if we did not look at the DNA from the bones.
Well, Joanna, now that's your minute done. Just under, actually, about 55 seconds, so well done. There is so much that we can look at in the future of the world, right? With the climate crisis, with humans travelling through space more. Why is it important that science looks at animals that went extinct tens of thousands of years ago?
Right, so this is actually exactly what I am interested in. I am interested in looking how animals are reacting to changes in the climate that have happened in the past. So in the past, you have ice ages, you have very warm periods, and I am looking at how animals react to that, if they move around or if they go extinct or what they do. And for me, the understanding of how and why animals changed in the past will really help us in understanding how they will change under the current, climate changes are ongoing, and how we can perhaps help populations and species when they struggle with the current climate change.
So you mentioned saber-toothed tigers there, and there are so many animals that we have heard of that lived so long ago. How many creatures do we think are undiscovered that we've never heard of from back then?
That's a good question. I think there are countless of animals that we just don't know are there, because when we look at bones, sometimes bones look very similar to each other, but actually they might be from different creatures. And we can really only find that out by looking at their DNA. So I think there's so many species that are undiscovered. So it will be a long time before we know how many there are.
And in your research, what amazing creatures that are no longer around have you learnt about that maybe we would never have heard of?
Well, I mean, the saber-toothed cat was really, or saber-toothed tiger, some people call it, was really one of the exciting ones, because when people talk about saber-toothed tigers, they think that it's just a single species, but it's actually multiple species that are extremely different from each other. And really only like the fact that they have these large teeth is what we recognize as making them saber-toothed tigers, but they're actually very different. And another species that we've worked on in the past is something called a macrochenia, which looks a bit like a cross between a horse and an elephant. So that's something that people might not immediately know has existed in the past.
Talking about saber-toothed cats, they look very mean, that they'd be amazing hunters and predators. And evolution is all about survival of the fittest. Why did it go extinct? What do we know of? Why is it no longer here?
That's a very complex question. There can be so many factors that can make an animal go extinct, there's, of course, the activities of humans that, have increased over the past that can drive an animal extinct. There's also climate change from, for example, going from an ice age to a warmer period, and some animals can't cope with that. There can also be sort of almost like a domino effect, where when you have one species that go extinct, that might have an impact on the next species and on the next species and on the next species. So it's very, very complex why animals might have gone extinct. And I think it's also very different for each animal.
Well, let me throw you forward 30 or 40 years, however long it is you want to carry on being a scientist at proper work for. What's the one question that you'd love to find the answer to in your career as a paleogenomicist?
I would really like to understand why animals are no longer around today in certain regions. For example, the leopard used to live in Western Europe, in this area, and they are no longer here today. And that, for example, is a question that I would really like to get a handle on. Why are they no longer here today? And should they be here? And if so, what should we do about that? So that is definitely what I would like to know in the future.
Well, it's a great fight for paleogenomics. Joanna Pymans from the University of Cambridge, thank you for joining us.
Right, thank you so much.
What do you think? Does that come top of our Battle of the Sciences leaderboard? It's hard to figure out who's top at the moment. There is a league table. I don't want to share it with you just yet because I need to get all the points, all the scores, all the goals for and against tallied. But it will come, don't worry. Thank you so much to Joanna. Loved hearing about animals there as well. So let's find out a bit more about them, shall we? With our trusty explorer friend, Marina Ventura, who is a genius. This is an episode from her Inside Biology series. She's getting up close to all different forms of wildlife. This time finding out about a bird's nest, what's inside, and how that creature's home isn't so different to yours.
Marina Ventura Inside Biology with the Society of Biology. Hold on tight.
Hi again. Today we're finding out about animal homes. They generally have a few things in common with our homes. I'll show you what I mean. Animals need the same things as us. Somewhere safe to rest, to look after their babies, and to shelter in if the weather is bad. If we look up high in these trees, we can see a bird's favourite home, a nest. Let's climb up a little to see. Each species of bird has its own style of nest. This is a magpie's nest. It's a spiky mass of twigs, grass and leaves. Just like houses, nests come in all sorts of shapes though. Some are like platforms, others are like cups, and you'll even find some in the ground or in the nook of a building. But they all do the same job, to make a warm, dry place where the predators can't get to them. Let's go back down. There might be sleeping baby magpies in there. Another cool thing is that birds are great recyclers. Man-made materials like plastic, fabrics, and even paper are sometimes used in nest making. At the base of the tree, there's another cool animal home. It's a badger set. That's the name for their huge underground burrow. We can just see one of the holes that leads in. Did you know badgers are amazing at housework? Don't believe me? Check this out. This pile of leaves and moss outside the entrance to the set looks a bit like it's been made by a person, but actually it's the badger. He's brought his bedding outside to air, a bit like putting it on the washing line. Amazingly, sets also have a separate latrine, or an area that's used as a loo, so they have their own ensuite bathroom. I wonder if MapApp has any other fantastic facts about animal homes.
Of course, I'll get beavering away on a great fact.
The electronic essential for every explorer.
And it's all about beavers. They're mammals that live around water. Although beavers are pretty rare in Britain, they're responsible for some of the most amazing animal homes of all. Dams. Beavers use trees, mud and stones to make a type of moat where they can use their swimming skills to evade any predators. They often work together to create huge safe areas for their communities, and one of the biggest dams ever made is so enormous it can be seen from space. Astonishing as it sounds, the dam in Canada, which is a massive 3 kilometres long, was snapped by satellites taking pictures of the Earth. It's thought it has taken nearly 30 years for the beavers to build it.
Amazing! Time for us to go, but we'll see you next time. In the meantime, find out more at funkidslive.com/biology.
Marina Ventura Inside Biology with the Society of Biology. Hold on tight.
And that's it for this week's Fun Kids Science Weekly. Thank you so much for listening. If you have anything sciencey that you want answered next week on the podcast, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com. We've heard from Marina Ventura today, got loads more from her and tons of brilliant podcasts wherever you listen to yours, Google, Apple, Spotify, and they're on our app. And Fun Kids, we are a children's radio station from the UK. Listen all over the country on that app at funkidslive.com. And if you've got a smart speaker, wake it up and ask it to play Fun Kids.